So we have here the torque. Torque describes the twisting and turning effects of force. So we have here a door who has a hinge at point 0. The door can freely rotate around this axis. The ability to rotate is directly proportional to the force. The higher the force you apply here on your doorknob, the easier it will rotate. Now the next one is, it is directly proportional to the place where you put the doorknob. So I want you to imagine these two scenarios. What if you put the doorknob here and you put the doorknob, another doorknob, in point B? What doorknob will make it easier to open the door, to rotate the door? Now, the answer there is point A. The further you are from the hinge, the higher you are, the easier it is to rotate. So this is the formula of torque. So the formula of torque is R times the force. So let's talk about the direction of your force. So what if you apply the force in this direction? Yes, that will actually open the door. But imagine if you apply the force in a parallel direction. Exerting the force in a parallel direction could not possibly open the door. So that is why the formula of torque, when it comes to non-90 degree direction of force, is a torque is equal to R, distance R, times the force sine theta, because only the perpendicular direction of force is considered. So if you will encounter torque problem with a certain angle, just use this formula. Now, what if you are given with vectors, a vector position and a vector form of force? When I say vector, it is written in a I hat, a j hat, and a k hat. So let's say your R is in that form, your F is also in that form. Therefore, you will be solving torque. Your resultant will be also in a vector form. Now, if that is the case, you will use this formula. The vector of the torque is equal to the position vector cross product with the force vector. Now, how to solve anything with a cross product? I will link the video here somewhere so you will remember it. Now, let's talk about the direction of the torque when, especially if it's in a XYZ axis. So I want you to imagine if you have a screw, you will use the right hand rule. The first, you use your 4 fingers to show the direction of the position. So the position is going there and the force is going here. So this is the position of our, so I want you to imagine your wrench, the handle of your wrench. So this is the handle of your wrench. And then you push your wrench. You push your wrench so that you will rotate your screw. So push. And then if you do that, there will be a rotation and the torque will be up. So the screw will now go up. Now, what if you have the other side? So we call it the right hand rule. With a force that's going in this direction, the torque will be down. So downward, so it means your screw will go down. So we call this the right hand rule for torque. Now, it is very important to know that we have the convention way of a positive and negative version of torque. Since we're talking about rotation, now a positive direction is the counterclockwise. So the counterclockwise will be the positive direction. So if this is the clock, the counterclockwise will be going here. This is the positive. Now, for a negative direction, we have the clockwise. It will follow how the clock will move. So this is a negative direction for torque. And that's it.